Hi everybody, Ms. Lee here. In this video, we're going to be talking specifically about normal distribution. So normal distribution is going to be a continuous probability distribution of a random variable x. So this is the official statistics definition of normal distribution. So let's go ahead and write that down. Okay, and so of course the normal distribution is going to look approximately like this. And so in this middle here, this is going to be your x bar or your mu, meaning your uh, mean. Okay, so this is the mean right here. And so each of these lines out here are going to be like a standard deviation away from the mean. So as we said before, a standard deviation was a number of like how that told you how like spread out a set of data is. It's the same thing here. So this is one standard deviation away. And so when you have normally distributed set of data, your standard deviation is going to happen at certain percentages, and that's what we're going to be talking about today. So this is going to be one standard deviation away. So this basically here is going to be x bar plus and then one standard deviation. So we use the little undercase, the lowercase sigma as standard deviation. And then this right here, of course, is going to be the minus of one standard deviation. So x bar minus one standard deviation. So x bar, again, is the mean. And then that little O with like a line at the end of it, that's going to be your lowercase sigma. Okay, and then similarly right here we have two standard deviations away. So this is going to be like plus or minus two standard deviations. So it's going to be like x bar plus two standard deviations. And then over here, x bar minus two standard deviations. All right, and this last one, so going from this to this, that's 1, 2, 3 standard deviations. So x bar minus 3 standard deviations. And then same thing right here. This is x bar plus 3 standard deviations. Okay, so this is a normally distributed curve, and that's kind of like how your standard deviations are going to look, either scaled in or scaled out. And so we'll go ahead and write some traits or properties of normal distribution. So as we said earlier, for a normally distributed curve, the mean, median, and mode are all equal. And so that's going to be right here in the middle. And that also makes sense because if you think about it, this is like the highest point. So that means it's the mode because it's the most where the most amount of data lies. And it's also the median because it's exactly halfway in between because you have the same amount to the left and to the right. And then the same thing with the mean. So this is going to be where the mean, median, and mode actually are. The normal curve, as we've talked about, is bell-shaped, and it's also symmetrical. Okay, so symmetric about the mean, meaning that the same thing happens to the right and to the left of the mean. So this is a symmetrical graph. Okay. The normal curve approaches but never touches the x-axis. So you'll see here that it looks like it touches the x-axis, but it actually doesn't. It's more so like an asymptote. It's an asymptote. Okay. Okay, and as I said, this can be like scaled like larger or smaller. And so if you have a larger standard deviation, then the more spread out or the wider the curve is going to be. So if you have a larger standard deviation, that means that this is, of course, further from the mean, and so then it would be wider. So the more spread out or wider the curve. All right, see you in the next video. Happy day.